Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss application of derivatives. Application of derivatives. In this chapter, we are going to discuss the sums in the exercise 6.5. We are going to discuss the sums in the exercise 6.5. Page number 232 in the textbook. Page number 232 in the textbook. We have completed question number 1 so far in this exercise 6.5. So let us start with question number 2. In this question number 2, there are 4 parts. Here I am explaining this first part. Question number 2, first part. Okay, my children, are you ready to listen the class? Yes. Find the maximum and minimum values if any of the following function f of x is equal to mod x plus 2 minus 1. Understood this question, my dear children? This question is also same as that of question number 1. Okay, my dear children? Here also we follow the first method. First method means without using the concepts of derivatives. Second method means by using the concepts of derivatives. Okay, my children. So here we are using the first method without using derivatives. Okay, my children. Right. Come to the solution part. Given f of x is equal to mod x plus 2 minus 1. Okay, my children. This is a given function. We wrote here. Understood this step, my children? Right. We know that modulus of any number is always greater than or equal to 0 for all x belongs to R. Whatever the number in this modulus symbol, inside the modulus symbol, then the value of this entire number is always greater than or equal to 0. Understood, my dear children? Do you know this fact, my dear children? Right. That is why we wrote this step. Understood this step, my children? Right. This implies we are subtracting 1 on both sides of this inequation. We are subtracting 1 on both sides of the inequation. So we wrote modulus of x plus 2 minus 1 is greater than or equal to 0 minus 1 for all x belongs to R. We are writing the same sentence as it is. Okay, my children? Understood this step? Right. This implies if we observe LHS, it is nothing but f of x. See here, f of x is equal to mod x plus 2 minus 1. Isn't it or not, my children? Yes. So, instead of, in the place of this function, we write f of x. Understood LHS, my children? Right. Greater than or equal to, what will you get here in RHS? 0 minus 1. What is the value of 0 minus 1? Yes, minus 1. Understood RHS, my children? Right. For all x belongs to R. Because f of x is equal to mod x plus 2 minus 1. Understood this step, my children? Right. If we observe this statement, f of x value is always greater than or equal to minus 1 for all x belongs to R. Means what can we say that here f of x has minimum value. We can say that f of x has minimum value, and the minimum value of f of x is minus 1. Minimum value of f of x is minus 1, which occurs when x plus 2, this number must be equal to 0. X plus 2 equal to 0. We are following the same steps as we followed for the question number 1. Do you remember these steps, my dear children? Right. That is x is equal to minus 2. By solving this equation, we got x value. So at this point, f of x has minimum, and the minimum value of f of x is minus 1. Understood this step, my children? Right. But f of x has no maximum value because f of x tends to infinity as x tends to infinity. Okay, my children? Understood? Right. Here I have drawn the graph of f of x is equal to mod x plus 2 minus 1. To make this concept very clear to you, I have drawn the graph of f of x. Then like this, the graph of f of x is like this. At x is equal to minus 2, at x is equal to minus 2, it has minimum value, and its minimum value is minus 1. Okay, my dear children, understood this concept? Okay, but if you observe this graph, it is going towards upwards. There is no ending, means it has no maximum value. As extends to infinity, it is going towards up. There is no end point. B means we can say that it has no maximum value as extends to infinity. Understood this concept, my dear children? But in the examination, you need not draw the graph of f of x. Just to make the concept very clear to you, I have drawn the graph of f of x. Okay, my dear children? But this part is no needed for examination. Just you write the previous part as answer, previous part as a solution to the given question. Okay, my dear children, understood? Right. This question number 2, there are total 5 parts are there. I have explained the first part. Okay, my dear children. Now I am not explaining the second part of this question number 2, because second part of this question number 2 is same as that of first part of this question. Okay, my dear children. Now come to the third part of the question number 2. Third part of the question number 2. Find the maximum and minimum values, if any, of the function h of x is equal to sine of 2x plus 5. Understood this question, my dear children? Right. Come to the solution part. Given h of x is equal to sine of 2x plus 5. Understood this step, my dear children? We have written the given data here. Understood this step, my dear children? Right. We know that minus 1 less than or equal to sine of 2x less than or equal to 1 for all x belongs to R, because the range of sine x value, sine x function, the range of sine x function is minus 1 and 1, close interval minus 1 and 1. Do you remember that point, my dear children? That is very important. Without using this result, we can't find the minimum value and maximum value of this function. This is important part for this question. Okay, my dear children? Right. Understood this step, my dear children? Right. This implies here we are adding 5 to all the sides of this inequation. This is one side, this is the middle side, and this is the right side. Okay, my dear children? So for all these 3 sides we are adding 5. So this implies minus 1 plus 5 is less than or equal to sine of 2x plus 5 is less than or equal to 1 plus 5 for all x belongs to R. Understood this statement, children? By adding 5 to all the sides of this inequation, we got this step. Understood this statement, children? Right. This implies, what will you get here? Minus 1 plus 5. Yes, 4 less than or equal to, we write the middle part as it is, sine of 2x plus 5 less than or equal to, what you will get here? 1 plus 5. What is the value of 1 plus 5? 6. Okay, my dear children? Understood? For all x belongs to R. Understood this step, my dear children? Right. This implies we write 4 as it is, less than or equal to. If you observe this middle part, it is nothing but h of x. h of x is equal to sine of 2x plus 5, the given function h. Okay, my dear children? Understood? So instead of writing this expression, we wrote h of x. Understood this part, my dear children? Right. Is less than or equal to 6. We wrote the remaining part as it is for all x belongs to R, because h of x is equal to sine of 2x plus 5. Understood this statement, my dear children? Right. So by observing this statement, h of x, the function values are lying between 4 and 6, including the values 4 and 6. Understood this statement, my dear children? Therefore, we can say that the function h has minimum value and maximum value also. In this case, this function having minimum value as well as maximum value. The minimum value of h of x is 4. This is the minimum value and this is the maximum value. Okay, my dear children? So we are writing that statement. Minimum value of h of x is equal to 4, which occurs when sine of 2x is equal to minus 1. Okay, my dear children? If it is minus 1 plus 5, where then we get 4. Understood this part, my children? Understood this statement, right, my children? Right. And the maximum value of h of x is 6. We get here 6, which occurs when sin of 2x is equal to 1. These are nothing but range of sin x. Least value of sin x function is minus 1, and the greatest value of sin x function is 1. So when these values are 1, sin 2x is equal to 1, then f of x has a maximum value. Understood, my dear children? Right. I am not explaining the fourth part of this question number 2 because it is also same as that of question number 3. Okay, my dear children? Now I am explaining fifth part in the question number 2, fifth part. Okay, my dear children? Try yourself, my dear children, whichever not explained, whichever the questions were not explained, try yourself, my dear children. And if you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children, is it clear? Right. Now come to the fifth part of the question number 2. Okay, my dear children, find the maximum and minimum values if any of the function h of x is equal to x plus 1 comma x belongs to open interval minus 1 comma 1. Understood this question, my dear children? Right. Come to the solution part. What is given here? H of x is equal to x plus 1 comma x belongs to open interval minus 1 comma 1. Understood this step, my dear children? We have written the given data in this step. Okay, my dear children? Right. Now come to this part. This is important. What are the values of x? X belongs to open interval minus 1 comma 1. Okay, my dear children, this can be written as minus 1 less than x less than 1. Isn't it or not, my dear children? Can we write this symbol? Can we write this notation in this form or not? Yes, we can write. Okay, my dear children? Right. This implies this is important part for this question. That is why we are using the less than symbols. Actually, they are given in the interval form, but the values of x are given in the interval form. So we wrote in the less than symbol form. Okay, my dear children, we wrote this same statement like this. Can we write it or not? Yes, we can write. Both denote the same set of numbers. Okay, my dear children? Right. This implies for this inequation we are adding on all sides of the equation. So minus 1 plus 1 less than x plus 1 less than 1 plus 1. Understood this statement, children? As we followed for the previous questions, here also we are following the same steps. Okay, my children? Right. This implies what will I get here? Minus 1 plus 1. What is the value of minus 1 plus 1? 0 less than. Observe this middle part, x plus 1. X plus 1 is nothing but h of x. So instead of writing this expression, we are writing h of x. Can we write it or not, my children? Right. We can write. Okay, my children? Less than 1 plus 1. What is the value of 1 plus 1? 2. Understood this statement, children? Because h of x is equal to x plus 1. By using this result, we wrote here in the middle part. Understood this statement, children? If you observe this statement, the h of x values are lying between 0 and 2, but they are not including. These two numbers should be included to find the maximum and minimum values, but here less than only, here also less than. So we can't find the minimum value and the maximum value. We can't say this number is the minimum value and we can't say this number is the maximum value. But if you observe the previous question, we got here less than or equal to, here also less than or equal to. Understood this difference, my dear children? But in this case here we got only less than, here also only less than. So we can say that h of x has neither minimum value nor maximum value. Understood, my dear children? Right. Now come to the question number 3. Question number 3. In this question number 3, there are total 8 parts are there. Total 8 parts are there. Here I am explaining the first part. I am explaining the first part of this question number 3. You try yourself the remaining questions by following the same procedure for this question. Okay, my dear children, listen these steps, my dear children, carefully. Okay, my dear children, right. Find the local maxima and minima if any of the function f of x is equal to x square. Understood this question, my children? Maxima means it is a plural form of maximum, and minima, it is a plural form of the word minimum. Okay, my children? Sometimes the function f of x has more than one local minimum values, more than one local maximum values. That is why they used this word local maxima. More than one values we get. Sometimes we get more than one value minimum for minimum values. Okay, my children, understood? Right. So for this question, hereafter we use the concept of derivatives. For the first question in the exercise 6.5, I have explained two methods. The first method is without using the derivatives concept, and the second method is using the derivatives concept. That second method is called second derivative test. That is called second derivative test. So hereafter we use the second derivative test. Okay, my children, don't be confused here, my children. We follow the same method, but terminology is second derivative test. That is that method is called second derivative test. Okay, my children, right. Come to the solution part. Given f of x is equal to x square, we wrote here given function as it is. Whatever the steps we followed for the first question in the method 2, we follow the same steps here also. What is the step 1? We have to find the derivative of the given function. Do you remember that steps, my children? In the first question for the exercise 6.5, first question, what are the steps here? First step is we have to find the derivative of the given function. That is, we have to find f dash of x. Okay, my children. So differentiating with respect to x, this implies the derivative differential operator is d by dx. So we wrote the differential operator on both sides of this equation. So then we get d by dx of f of x is equal to d by dx of x square. Understood this step, my children? Right. This implies, how do you write this notation d by dx of f of x, f dash of x, isn't it, or not, my children? Right, is equal to d by dx of x square. How do you find the derivative of this function? It is in the form of d by dx of x power n. So by using that derivative formula, n into x power n minus 1, then we get here 2x. Understood, my children? Right, because d by dx of f of x is equal to f dash of x. This can be denoted by f dash of x, and we used this formula d by dx of x power n is equal to n into x power n minus 1. Understood this step, my children? These all the steps are come to under the step 1. Understood this one, my children? Right. Now step 2. In step 2 we are going to find f double dash of x. Do you remember that steps, my children? Total 4 steps I told you. 4 steps in method 2. We follow the same method, same steps. We follow the same procedure here. It is called second derivative test. Okay, my children? Right. Again differentiating with respect to x. This implies d by dx of f dash of x is equal to d by dx of 2x. Okay, my children? What we are doing? Understood here? We are finding f double dash of x. For that, again we differentiated with respect to x. Understood, my children? Right. That implies f double dash of x is equal to 2 into d by dx of x, because here 2 is a numerical coefficient, so we wrote 2 before the differential operator d by dx. Understood this step, my children? Because d by dx of f dash of x, this can be denoted by f double dash of x. This is the notation. Okay, my children? Understood? Right. This implies we wrote LHS as it is f double dash of x is equal to 2 into What is the value of d by dx of x? Yes, 1, because d by dx of x value is 1. Understood this statement, children? Right. This implies f double dash of x is equal to, what we will get here, 2 into 1, 2. So if you observe this value, f double dash of x value is 2. It is a positive real number, means it is greater than 0. Then we can say that f of x has local minimum value. If we get here f double dash of x greater than 0, we say that f of x has a local minimum value. On the other hand, if f double dash of x less than 0, we say that f of x has local maximum value. Understood this difference, my children? Right. Now come to step 3. Do you remember that steps, my children? What we have done in step 3, finding the critical points or turning points or stationary points. In step 3, we found turning points or critical points or stationary points. To find them, we have to solve this equation, f dash of x is equal to 0. We have to write this equation and we have to solve this equation for finding the values of x. Understood the my children? The values of x is nothing but critical points or turning points or stationary points. They are said to be critical points or turning points or stationary points. Understood this point, my children? Right. This implies what is f dash of x? We have already found, that is 2x is equal to 0. Understood this step, my children? Right. From this equation we get x is equal to 0. So we got here only one value for x. Sometimes we get more than one values for x. We have to substitute all the x values in the next step. What is the next step? Finding local maxima or minima values. Here we got only one value for x. Sometimes we get more than one values for x. We have to substitute all the values of x in this step 4 in f of x. In f of x only. Understood, my children? Then we get f of 0 is equal to 0 square, that is equal to 0. This is the value of f of x at x is equal to 0. Understood these steps, my children? Remember these steps, my children. These are very important for the next upcoming questions, because we are using the second derivative test only. Okay, my children? Right. Therefore, f has local minima at x is equal to 0, and local minima value of f is f of 0, that is equal to 0. Understood, my dear children? Right. Come to the question number 4. Question number 4. In this question number 4, there are 3 parts. 3 parts are there. Here I am explaining the first part. Okay, my dear children? You try yourself for the next 2 parts in this question number 4 by following the same procedure, by following the same steps. Okay, my dear children? Right. See this question. Prove that the function f of x is equal to e power x does not have maxima or minima. Understood this question, my dear children? We have to prove that the given function does not have maxima or minima. Okay, my dear children? Now come to the solution part. To prove this statement, we follow only 2 steps. Remember these 2 steps, my dear children. First we write a given function f of x is equal to e power x. Okay, my dear children, understood this step? Right. In the step 1, we find f dash of x. Do you remember that one? How to find f dash of x? Yes, differentiating with respect to x. This implies we write the differential operator d by dx on both sides. So d by dx of f of x is equal to d by dx of e power x. Understood this step, my children? Right. This implies if you observe LHS, d by dx of f of x is there. How do you denote this d by dx of f of x? We denote this part as f dash of x. Understood LHS, my children? Right. Is equal to d by dx of e power x. This is the standard derivative formula, e power x only. What is the value of d by dx of e power x? E power x only. Okay, my children? Because d by dx of f of x is equal to f dash of x, and d by dx of e power x is equal to e power x. By using these 2 results, we wrote this step. Understood this step, my children? Right. Now come to the step 2. we follow only two steps, my dear children, for this question to prove the given function does not have local maxima or local minima. Okay, my dear children, showing that f has no critical points, we have to show that f has no critical points. So we solve the equation f dash of x is equal to 0. We solve the equation f dash of x is equal to 0. This implies, what is f dash of x? We got here e power x. E power x is equal to 0. In this question, we need not find f double dash of x. Okay, my children, please remember this point. So e power x is equal to 0. We got this equation. Okay, my children, if you observe this equation, we can't find the value of x in R such that e power x is equal to 0. We can't find the value of x in the set of real numbers such that e power x is equal to 0. Therefore, we can say that f has no critical points. Understood this step, my dear children? Right. Thus, we can say that there is no point at which f may have an extreme. Extreme values means minimum value or maximum value. Okay, my dear children, understood this step? Right. Therefore, f has neither a maximum or nor a minimum. Understood this step, my dear children? Right. Hence, proved. The given statement was proved. Okay, my dear children, understood? Right.